So I did my undergrad in France, where I'm originally from. I did my master's and my PhD in the UK. I worked at Microsoft in Beijing, which is where I met James Landay. Then I came to do my postdoc with him in the US, Cornell Tech, and then Stanford. And then I opened my research lab in Israel 6 years ago. So I've pretty much lived everywhere, and I've traveled intensely through South America and Africa. So if you have any questions about international career at some point, I'm probably a good point of reference, and I'm happy to tell you about it. Today, we're going to talk about on-body and out-of-body experiences. As I was building that talk, I think we're going to work more on the out-of-body experiences, but I can also tell you more about the rest. So if we think about technology and technological evolutions, we had different times in our evolution where things change for us as human beings in how we work, how we function. And so we have the printing press, we have the steam engine, and everything changed. We have this industrial revolution, and now people are talking about the fourth industrial revolution. Some people are talking about the fifth industrial revolution, even though we're not quite done with the fourth one yet. So we're all kind of figuring out, what does it mean to live with technology? And if I think about it right now, and I ask you how many of you have a phone with you right now, and whoever is not lifting their hand, I know you're not paying attention to the talk. And whoever has a smartwatch with them right now, and a laptop with them right now, and then I can go with any other types of devices. So we're very much connected. We're all the time connected, but technology is changing. And so one of the main challenges is, how do we integrate very different types of technologies? And so if we're looking at this image, we now have a robot citizen. What does it mean for us to live in a world with a robot that is a citizen? It's very different from just having a phone and an object to work with. And so if we think about machines, how do we imagine coexisting with them? How do I live with a machine around me? How do I integrate it into my daily life? So I really like this image. Are they going to take over? Because this is what people are worried about. I mean, if you go out of Stanford in the Bay Area and you tell people about AI, people are freaked out. Governments are making decisions because they're worried about, what does it mean for robots, AI, to take over decision-making, to take over our human abilities. And these are, we're laughing about it because we're working on it, we're developing this technology, but people are worried all over the world. These are big questions. And so, is it humans who have to now support machines? And that happens all the time. Whenever you have a problem and someone goes like, oh, I can't, the computer won't let me. It's like, okay, clearly this is an HCI problem. But very much, there is this fear in our society. How do we live with automation? And so we can imagine a better version, and this is the one I want to reassure you with and that I want to think about, is like, I don't quite believe they're going to take over. I don't believe this is the future we're going for, but they may coexist with us. And this is something we have to think about. If we think about autonomous cars, we could say, okay, we divide the lanes, and half of the lanes are for autonomous cars, and half of the lanes are for the other people. Because building a system where everything is autonomous, easy. Building a system where half of the cars are autonomous and half are not, super, super, super difficult. And so one way to go is to say, okay, we leave half of our world, half of our space to technology, and then they can do their own things. But we give away half of our space. I mean, we have to rethink. Do we want to do this? Do we want to only have half of the world for us and half of the world for machines? Or do we say, okay, how do we build machines? How do we build automation to work with us, to coexist the same way you have technology with you in your pocket, on your body right now? How do we do this? And so this is really the vision I want you to have in mind, and this is a vision that we're having in my lab. And so I'm going to give you an example of drones in firefighting. So in Israel, we have a lot of fires. I'm not going to teach you anything. California has the same geography and very, very, very similar problems. And fires are a major problem. And so drones are being used right now to support firefighters into their jobs. But it's not obvious. And so we met with the 3 top experts in the country. That's the advantage of living in a very small country. So we met with the first intelligence officer of the Israeli firefighters, the operational R&D officer, and the head of drone and aerial forces. And this is what it looks like. So you have firefighters, for example, in a building, can be indoor, can be outdoor. Here we're looking outdoor. you have a mission commander, and very often what they do is they bring a drone operator. And so when the firefighters need some help from the drone to get some situational awareness about what is happening, they ask the mission commander about it, who asks the drone operator, who moves the drone, who gets feedback from the drone, who then gives the feedback to the mission commander, who gives it back to the firefighters. Can you see how many channels can go wrong here? And this is what's happening today. We're not inventing anything. And I'm pretty sure the example of what's happening in Israel is very similar to a lot of other places, very representative. It is hard. It's hard to control a drone. It's hard to control a drone in an environment with a fire, with wind, with different elements happening. And on top of it, it's very hard for the firefighters to actually get this real-time information. And here, obviously, they need real-time information. If it takes 10 minutes, not worth it, probably. They need to know in real time what is going on. And so our idea was to say, could we just cut down the middleman? Can the drone be part of the team? Would that even be an option? So the firefighters walk into a building, they give instruction to the drone like any other team member, and then they get the feedback in the same way. So we actually worked with elicitation studies. So we met with some of the firefighters. For those of you who have worked with firefighters, with like emergency personnel, what's really fun is you start doing a study, they have an alarm, and half of them run away. You have to wait several hours to finish your study. It's a very different way of doing research than when you invite 10 students to come and talk to you. But anyway, we still managed to get a lot of interesting data. What we found, and that was very surprising to us, is we did not want to assume that they would use gesture to communicate with the drone, because they have a lot of equipment. They have gloves, they have helmets, they have a lot of equipment with them, but they're very low tech, which is also was really weird to us. They're very, very low tech. They have a radio, and then that's kind of it. And they're basically going for it. And so they told us they actually wanted to use gestures, because to communicate between each other, they mostly use gestures. But what they do is they use very big gestures. Again, as a gesture designer, I would probably have done very small gesture because they already have equipment and things to carry. So I probably would not want to impose bigger gestures. But because they communicate with each other with those larger gestures to make sure that they are seen, they wanted the same thing to communicate with the drone. And so here, those are like examples of 4 different gestures and 4 different actions that they would need help with. And this is a paper that was published at Mobile HCI a couple of years ago. So we worked with them, we found the right gestures that they wanted to implement that fitted with with the way they work. But then the next question is, can we get the drone to actually recognize those gestures? Because this is not the obvious one. And what's interesting here is we work in a harsh environment. And again, there are robots working in harsh environments today. But when we went down to the literature, there is very, very little work on gesture recognition when there is smoke or when there is heat source, or very, very little. And so we wanted to see, we have this unique challenge of a very peculiar environment that is very complex for sensing and for recognition. Low visibility, some heat points, it's not trivial. And so we said, okay, let's try to imitate this environment. So we use the same equipment that they are using. So we try to refer to the harsh environment literature, even though it's very sparse. And then we decided to compare existing sensors. So we decided not to build our own sensors, like some of you are doing in your PhDs, but to say, okay, we have a lot of sensors that exist. Can they even detect? What sensors can we use in these conditions? So we use 3 sensors, RGB, so just a basic camera, basically, depth, and thermal camera. And then we tried different algorithms that are well known to try and see, can we actually recognize? What's really interesting here is the depth camera could not get anything when we had smoke and equipment on. We knew it wouldn't work perfectly, but we had hopes. We were like, it is gonna work some. No, it's not working. And we use like a special indoor smoke machine that is used to recreate this type of environments. And actually, we could not get anything interesting out of it. Thermal, we did not have any heat source in our study, so we decided to first try just with the low visibility, but without the heat source. already without the heat source, we had pretty poor resolution. So if you add a heat source, then it's kind of game over because then the camera detects something else. And so RGB actually performed the best. And we do a lot of work with drones. Often we use depth cameras because they are less sensitive to low visibility environment, except when there is smoke. And here we got something more interesting here using the RGB. So again, here the innovation for our work was not in designing the best sensor or designing the best algorithm, but to see what are the sensors and algorithms that exist that we can use to actually do this type of research successfully. And we had pretty good results with like 90 to 98% recognition. 90% is not good enough, by the way. So sometimes when you're doing something that is not in a harsh environment, that is not with active duty personnel, 90% is amazing. It's like, okay, worst case, people will try again. When you work with emergency workers, 90% is not good enough. It's like, sorry, wrong number. So it still needs to get better. So there's still more research to be done, but it shows us that there is this possibility. We could actually get something pretty good here. And so, okay. And so the next step for us was to say, okay, so now we know, yes. Oh, sorry.
I was just curious, for the depth sensor, are you using where it's 2 cameras and they're doing the change in the different options, or are they actually using light?
No, we were using like dual cameras on this, yes. And so the other thing is now when we work with trained personnel, you work with people who know what is a drone, they know how it works, they may know the limitation, they may know what works, you can train them. If the drone does this, it means that. So worst case, you just train them longer. And that's something also to know in HCI. We often try to do something that is natural, that is efficient, that works 100% of the time. But actually, if you look at aerospace engineering and others, it's very hard, for example, to work on an airplane. But it doesn't matter. You have super bright people and you have as much time as you need to train them. That's the beauty of it. So even if your interaction is not the most efficient, you have trained personnel. And that works with a lot of those actors. The problem is now you have people on the other side of this. So when you have, for example, so this is a search and rescue scenario, you have a person lost. If the emergency personnel is using a drone, fantastic, but how does the person know that the drone is coming to help them? How does a person know that the drone saw them? Because they're very black boxy in many ways. It's like, I don't know what's going on inside. It's just a drone, it's just a machine. I don't have much information. And so here, those are videos we took in the Judean desert, so it's close to Jerusalem. It's super, super, super beautiful. It was a very, very hot day. It was like something like 50 Celsius. It's like, what, 110? My students still hate me for it. But basically, this drone is coming. It has a very simple interface, but it's telling this person, I'm looking for that other person. Have you seen them? And we created this very basic interface. And we found that just by showing this interface with 2 different colors and 2 different options, people actually just point to it. So that's a very natural interface here. And here the drone keeps looking, so they didn't find the right person, but they're going to try and find the right person. So now this person actually wants to be found. This person is lost or injured, they need help. So they're happy to see the drone. You have to realize the other person may become aggressive and not want to see the drone. But here this person wants to see the drone, and so they're much more willing to communicate with it. And so again, we've been looking at how could, for example, the drone be dropping some equipment. This is not 100% working, but this is another type of research which we're not doing right now. But the idea is that, and this type of drones actually can carry a lot of weight. They're quite impressive. There's a lot of noise and wind around them and sound being blasted. But actually the idea is that we could help, for example, a search and rescue team doing triage. So the person could say, if they're injured, what is their injury and pain levels? So we actually talk to search and rescue teams that would tell us these are the first questions we would ask. So first, obviously detecting if the person is conscious, which a drone is capable of doing today. There are people who work on recognition who can do this. And then if the person is conscious, if the person is alive, then they can start answering questions. So we could totally imagine a swarm of drones going after a major incident, like an earthquake, for example, going to find different people, and then the team actually gets much more situational awareness and can do triage. And then people actually know what's going on. Because right now, when you have something happening, people may see helicopters or something. They don't know if they've been seen. They don't know when help is coming. Nothing is staying with them. And drones can be actually very cheap. I mean, compared to a helicopter, it's crazy cheap. So you could send easily 100 drones for one helicopter and get all this data at once. And then on the other side, you can make sense of that data without scaring the person away. Yes?
So in these examples where the person's interacting with it, is there also like the drone like speaking?
So yes, so in this scenario, we tried speaking and visual. So we found that visual only usually works, but speaking makes it more personal. So in a way, people are more likely to look at it. When people are in need, and the problem is, it's really hard to test someone in need, right? You can't really like take someone, break their leg, leave them in the desert, and then just send a drone and be like, oh, look, they were happy to get it. Ethics approval, IRB boards are not super open to this type of research, you have to know. And so one of the difficulty here, you can only simulate. So you tell people, oh, imagine you would be lost. Imagine you would be in this situation, your phone is not working. This. So we would give people an idea of what the situation is. But it's never quite the same as trying it in real life. And those are the limitations right now of this type of research. But what we find is when there is voice, people are much more likely to like pay attention to it. So for example, the person who doesn't want help, who doesn't want the drone, who doesn't really want to help the drone, if they realize the drone is here for medical purpose, for emergency purpose, they're much more willing to help it. And this is something I'm going to talk about in a few minutes about a different project. So you have to basically convey a minimum amount of information to people of why is this drone here. If people just see a drone, the first instinct is what? Can you guess? Run. Run. Usually not. Hide, you said? Not quite. Throw something, potentially.
Like, ooh, something cool, look at that over there or something.
So that would be great, but people tend to be much more negative. Like what we found is people see a drone and like, oh, there's somebody like taking my picture. And people are worried about privacy. Again, this is very culturally biased. And so we've done actually several research in different countries. Yeah, for example, we found that in Asia, people were much more open to drones and much more positive about it. Like we had a study in Korea and people were like, oh, the drone could do this for me, could do that for me. And they were like so happy and excited about it. And then we did the same study in the UK and people were like, oh, it could be a terrorist. And we're like, okay. So it was really interesting how, based on your own awareness of what has been happening, what you saw in the news, what's going on, I guess, politically within your own country, there's very big differences in how people perceive those drones. But very often in Western culture, what we find is that people are scared. People get like, oh, somebody is like taking my photos, taking my videos, I really don't want to be there. And so if you know that the drone is here for medical purpose or for search and rescue, people are much more willing to share the space with it. So going back to the very first slides, to coexist with it and even to help it. And this is what I'll get to in a minute. And so this is a notion of drone-initiated communication. This is actually a paper that we're going to be presenting at CHI in a month, I guess, just about a month. And basically the idea is like, we don't really have machines-initiated communication. If you think about it, no machine really comes and talks to you. Even if you think about your phone, it rings, so it notifies you, but it's your phone, it's with you, you know it may ring. It's a choice you've made to have a machine that may ring to tell you there's a communication. But it doesn't really just start talking to you. The ATM doesn't just give you cash. You have to go to ask for cash, hope that there's money in your bank account, and then you get the cash. The ATM is not like, hey, come on, here is cash. No, it doesn't work like this. Machines don't just talk to you, and the few times they talk to you, it's weird. Like when Siri starts talking to you and you weren't talking to it before, it's like, hey, I didn't talk to you, go away. It's kind of like, it's really weird. And so in robotics, there's been a lot of work on this machines initiating communication. And even then, we're still more used to us going to ask for help from a robot than a robot coming to us for help from us. And if I go back to the road example, let's say we have an autonomous car on the street. Okay, so it does its job. But let's say something fell on the street, a scooter, anything. The autonomous car cannot take it away from the street. Like if you were a driver and there's a problem that's not supposed to be there, you go out of your car, you take it out, you move it out to the side, and then you continue. An autonomous car can't do that. So it's going to need help from people around, from bystanders. But it's something we don't know how to do yet. How do you ask bystander to help, to be willing to help an autonomous device? And so one of these aspects is, how do you even initiate this communication? And so if we look at the literature in human-human communication, there are 3 stages to initiating communication. The first one is you start the communication, you maintain, and you end. It sounds super obvious, and it is, but it's not so obvious everywhere. And so the idea is like, here's how engagement works. So the person who did this work is called Kendon. This is a model that dates back from the 90s. And he says the first thing is sighting. So I looked at you. Now I'm looking at you, you know we made eye contact. Now if I start walking towards you, chances are I'm coming towards you. And so we have all these very simple cues in human-human communication that tells us we found each other, we saw each other, the person is coming, they're coming, okay, at some point they have to stop, and if they stop too close, it's kind of scary as well. So you have some spaces where you're comfortable and spaces where you're not. But we have a very, very long literature in human-human communication on how to do this. Now, so it's like this 6 stages process: sighting, distance salutation, approach, final approach, and close salutation. You have to stop, this is the main thing. Otherwise, the person collides into you, and this is a whole different problem. And the transition, it's funny, but it's actually not. It's like at some point you have to stop. When you meet a robot and the robot doesn't know how to stop, like there is collision, and it's actually a major problem in automation. If we look at the literature on drone, different people have looked at different aspects of it. So some of the work is also from my lab, but nobody looked really at the whole process. And so we wanted to see, like, can we recreate that process in drones? Because what happens is, like, the difference between approach and final approach is very minor. So for example, I'm approaching you, and at some point I'm gonna just slow down a bit. And it's very, very small. But we're able, in human-human communication, to pay attention to this. But the question is, can we, in robotics or in drones, actually make a difference between this approach and final approach? So from the work we've done, we don't think we can. And so now we have created approaching as 1 step. And we created a 4-step process for a drone to come, find a person, and interact with them. And now the idea was, okay, we have this 4-stage process that theoretically should work. Now, can people recognize it? And how do people know? So we tried to use light, expressive light. There's a lot of research on how to express states of technology through lights. So it can just be like one light tells you it's on or off, for example. You have one here. I have a green light. Just with this, I know it's on. If it's red, probably I will assume it's not working. So we have small assumptions of things we already know from prior technology. The advantage of light is like it can be seen in the day, it can be seen in the night. It's very lightweight, very easy to integrate. You can just add light onto something that already exists. And I'm just going to show you what it looks like. And we created different patterns. And so we built it off prior work that had been done on selecting states of different types of technology. And the idea was like, can I actually get people to recognize those states? The way we built it was very simple. We just used an Arduino board. I've seen some of the projects yesterday. It's like, you know how simple it is to implement those. So it's really cool because we can take any commercial device, any commercial drone, and we just fit light on it. And we had these 2 configurations, so the strip and the rings. And the idea is that the rings kind of make it look like eyes. And this is part of the work we've been doing over the years, that we found that actually people anthropomorphize robots and drones, and based on this anthropomorphization are going to make other decisions. So this is something we wanted to keep and compare. So we initially ran an online study with 156 people. We showed them 26 visualizations through video stimuli and a questionnaire to see if they could understand some of the states. So we actually found that some of the states, so the gray ones, matched our criteria. So again, I'm not going to go too deep into each aspect, but you can find more in the paper. I can also tell you more later, but we found that specific animations were better at representing specific states. Then we looked at colors. Does the color of the LED matter? And we found that actually for searching, people were more comfortable with blue and red, for spotting with red, for approaching with orange, and ready to interact with green. So we already had like some notions. Again, there's a lot of research that shows that color preferences are cultural, but we're going with like the more generic research here. So now from this, we're actually able to have a sense of what are people preferences. And now the idea was to say, we did this online study. It seems that there are some colors, that there are some patterns that people will be able to understand. But now, what does it look like on a drone? Because the drone is already moving, and movement is an important component. We knew from our prior work that movement is not sufficient. It conveys a lot of information. You can see it coming towards you, but you don't see it's going to stop. You don't necessarily know it saw you. So we wanted to combine the movement of the drone, normal behavior, with the lights, and to see how that worked. So this is actually a top view of like a little garden we have on campus. It looks like a fake image, but it is actually the real image just from the top view. And the idea was to validate our findings in this in situ study. So we actually ran 45 participants in 3 different conditions. One condition was with 15 participants looking at a baseline, that they were only looking at movement. And then we had 2 conditions with a different configuration. So baseline, strip, and ring. And then we had questionnaires and interview. So we asked people to sit down and just to explain to them that they were in a search and rescue scenario, that they'd been injured, that they were waiting for help to come. They didn't know a drone was coming. They just were waiting for help. And then they saw that drone come. So when we look at the recognition rates on the different things, so you can see there's a major difference between the baseline and the strip and rings condition. So just with movement, people were able to understand the searching and the approaching states. But for example, for the spotting and ready to interact, they were not capable of recognizing it just from the movement. We're like about 25% of recognition. So it means that the light did help. They did provide strong help. Now, when you look just at the recognition rates, it looks like strip and rings is very similar, but we actually found other differences between the 2 configurations. And so one of the things is people were like, this is super intimidating. They were pretty worried about it. It's like this machine is looking at me and it's like red. And so this was about the color. When, for example, with the green, people were like, oh, it means everything is okay. So again, just from the color, we were seeing some differences. And so anyway, so this was a very big piece of work in the end because we had a whole chunk of studies. The paper will be presented by my student Eyal. It was the end of his master's degree. So I also think like for master's students to have run like that amount of work, it's pretty impressive. But he was able to basically find specific animations and colors that would be what we think today the best way of conveying this type of information that people can actually recognize and feel comfortable about. Now the next step of this work, so now we know that we can have this drone, that they can convey some information in pretty simple way, that people can recognize, that can be integrated into teams. But actually, are people willing to help them? Because what we found is, like I was saying for the car before, sometimes they need help. If you send a drone, for example, to deliver something to a house, it may not be clear which house which house number. Sometimes it's not, written very well. It's not very clear. As people, we can just ask the question, can drones communicate with bystanders? And so this is part of a very large project that we conducted with the University of Oldenburg and Susanne Boll's team. We worked on the drone side, they worked on the robot side, and the idea was to say, if in future cities we have these drones and these robots for last mile delivery, and the whole idea was around sustainability. There's a whole other aspect of how you get funded for sustainability to do drone research, but that can be it's about being creative and explaining why your research is important, but that's a side note. But basically the idea was to say, throughout the COVID, we've seen people not being able to get healthcare services, for example, or to have healthcare workers coming to their house and actually putting them in danger because the healthcare workers themselves were more exposed. And so you could have those little drones and robots delivering medical services or medical equipment to people. And this would be super useful. And again, we did other pieces of research on this. This is very acceptable. People would be very willing to work with those drones, to even have them like come through their windows if it can provide this type of help. And now the idea was, how do we design them in a way that bystanders are not going to want to like throw something at them, which was a suggestion earlier when I see a drone, but to understand this is a drone that is coming to help someone. Can I help it get to that place it needs to go to? And so this is kind of the process. So we did it in 3 stages. Co-designing the different AVs, co-designing the vehicle on the ground. So we looked first at what does it mean to have an AV for healthcare. Then we looked at more specific appearance, interaction, how does it present information, and then how does it communicate. So we really had this multiple stage process. We started with a bunch of focus groups. We had different discussions with different people to really get the opportunity also for them to design. And then we validated this with our own prototypes. So I'm going to go fast because I won't tell you about other things. But these are examples just from like co-design workshops. And what we find, and it's interesting, so we did it across 2 countries. What you see on the top was done in Israel, and what you see at the bottom was done in Germany. And huge, huge similarities in how people were thinking about them. So for example, people were saying, oh, it could have a red cross. So the red cross is one of those distinct signs that people will recognize as healthcare services. What's also interesting is because in Israel, we don't have really the Red Cross as much. We have Magen David Adom, which is a different organization with different colors. Still, the Red Cross is like very, very strongly ingrained into our cultures, maybe also through movies and others, that this is a sign for like medical help. There are different things about anthropomorphism and how it should communicate, and I'm not going to go too deep into it, but basically the idea was this, that it should have bright colors, that people should be able to really see it, hear it, understand when it's like into an emergency or non-emergency mode. So we found like specific criteria like this that needed to be implemented. From this, we've created different prototypes, and then the idea was to test it. So this is a very large drone cage. It's probably the biggest in Europe at this point, which is located at Enac, which is in the south of France, in Toulouse. So I'm actually currently on sabbatical in that lab, and they have this incredible facility to do drone research because they have this like 10 meter by 10 meter by 15 meter drone cage. We're building one in Israel right now, but building anything in a university takes time. I don't know how long it will take for your building to, your next building to come to life, but it takes time and effort. So my drone cage is still under construction. So in the meantime, I could go there to run the study. But the idea is like we have a tracking system that enables knowing exactly the position of the drone, exactly the position of the person. And so we can do some really interesting work also into knowing the micro movements of different people. I'm not going to get into the micro movement here, but the idea is we really went with 2 main conditions. One condition was that the drone would do its own thing. So the person had like a task about walking into a city, going to say hi to someone, bring something, and then the drone would do their own thing. And in the second scenario, the drone would ask for help. And we wanted to see how people would react to the different scenario. And so this is what it looked like. So basically, the study was like welcome, consent, introduction. They would go through condition 1 and 2 or 2 and 1, and then interview and questionnaires. And so what's really interesting here, so I'm mostly going to focus, again, it's very, very large studies across like 2 different labs, 2 different countries. It's a paper that we submitted right now to DIS, so we're waiting to hear. But I really want to show you the difference between the drone and robot. Does it make a difference to have a different style of automated vehicle? Because what we found is that when we showed them, when we did the co-design workshops, they wanted the exact same things for both types of vehicles. So is it the same? And so if we look at the noise, so this is about acceptability of robots on 3 different scales. there's no difference between them. So people are pretty happy for it to be relatively social. I should have put you the explanation, but basically the last one is about the drone being more emotional and communicative, so that was less, but it's the same between the two technologies. The Godspeed questionnaire is a traditional robotics questionnaire, so in terms of likability, it was pretty much the same. In terms of intelligence, they found the drone slightly more intelligent, but it wasn't really significant. And in terms of safety, they felt about the same in terms of safety. They were still pretty positive about it feeling safe, which is always a big question, because to be really honest, those technologies are not super safe today, but people feel safe. And this is a whole different problem, but this is something that we found. This is another questionnaire that we looked at. So what's interesting here is we saw some major differences between the two technologies. And here what we found is that they felt the drone was more informative in their interaction. We implemented the same thing between the two technologies. We designed them to look like each other, just different shape of devices. They found the drone to be more useful. They found it to have more social presence, like a lot more social presence. It's here. And they found it more trustworthy. Now the whys, yes. So I don't have all the answers. I mean, we just finished this research, so now we know where to push the next questions. We think that the position coming from above gives it this impression of being more personable, more relatable. That when you look at something down, especially it's something that is small, that is quite low, that people tend to like look down upon it, like literally. So, no, but this is really like what we found in some of the literature as well in robotics. When you have like bigger robots, people tend to be like more and finding them more trustworthy, more intelligent when they're smaller. So it might just be a size or a positioning issue, but I think it does raise some major questions on what does it mean in like, so it's brand new. We just finished the research, but this is what we're going to look at next. Because they were designed very, very, very similarly.
It's interesting because in the CSCW literature, like the old school, Judy Olson finds these results that say, like, the camera position in the direction that it's looking, that you perceive, changes the sort of status and hierarchy.
Yes.
So, like, if your camera is always up here, so it always looks like the person's looking down on you,
yes.
It actually, like, they perceive that they have higher status and so on. Whereas if they're always looking up at you, you should always mount your camera under your display, I guess. And it seems different here, which is interesting, right? If you look at these things of like status and informativeness and usefulness, yes. You'd think that if I have to look up to it, like I'm sort of like worshiping it. It's interesting here.
But I think there might be some of this. And so what's interesting is, I wasn't going to really talk about it, but right now we're working on a project in Toulouse where they designed this crazy flying platform. It's like this huge drone with like 8 different propellers, and they put a robotic arm on it. And the idea is that they could help a worker at altitude. So let's say somebody is like working on a ladder and then they forgot a tool, then the drone can come and bring it to them. And there's this like robotic arm to give it to them. But all the literature on handover is always looking at objects that are taken from down or just in front of you, never from above. And never when you're in altitude yourself or working on a roof or something like this. And so I think there's also something really interesting into like, how do we use those results to build the interface for this co-working drone, thinking that people may, for example, trust it too much. Because this is also a problem with trust. You want people to trust your device. I mean, if you build a technology, you want people to trust it. But what's important is that they trust it the right amount. If your device is not secure, and we have prior research that shows, for example, that drones have propeller guards, they tend to be less seen as, they are seen less safe as when they don't. They are safer with the propeller guards because they avoid collision. But the look and feel of it makes it look maybe more scary, and so people find them less safe. And so there is really a mismatch between people's expectation of looking at the technologies and what is actually happening. And so how do we take this into consideration into building future interfaces? Yeah, those are huge questions. Yes?
If I know I'm in a city and I see a drone, I feel differently than if I'm just walking on the road and a drone approaches me.
Yes, so great question. So it's actually funny, we were talking about it this morning in one of the one-on-one conversations. So we had a study, for example, a few years back looking at how people would react to their first encounter with a drone. And so what we did is we did a post-consent study. So we actually had like drones flying into the city, and yep, this is very much what happened. Filming people, filming their reactions, and then we would like, well, not me, but my students would be running after them after to ask for consent. Like, can we actually use this data? It's like, don't go. And so it's kind of interesting. So from a study perspective, we really didn't know how to do it because we wanted to capture this type of interactions that we don't usually get to capture in very like lab-style research, but at the same time, from a IRB and ethics perspective, it's much more complex. So we've talked to a few people, especially people who worked like Wendy Ju when she was working at Stanford. They had all this thing with the ghostwriter, and so I asked them how they did it. And so they had this post-consent. So the difficulty is you have to throw away a lot of your data. Because if people are not willing to use it, it's like, let's say you get 30, 40, 50 people and only 20 say yes, then you only get 20 data points. And there's probably a bias from the people who said yes, that they were probably less frightened. I think in Israel, privacy is less of a concern in general. Like, nothing is private. People don't care about privacy. Like, you have a lot of conversation. Like, someone in the room could be like taking a conversation on speaker while I'm talking, and not even, and not even feel this is a problem. It also happens in the movie theater. And so I think people are a lot more open to things and don't care as much about privacy. So we actually had pretty high amount of the people who accepted that we use the data. I think if we had done the same research here or in Europe, like for example in Germany, where people are very, very concerned about privacy, I think it would have been a very different ratio. But again, you work in the context you are. So based on what you're trying to find out, you build your study, like with any other HCI experiment. So sometimes you can do things that are more controlled, sometimes less controlled. But it's actually hard to do this type of research in something that would be like real world. So you try to get it as close to the real world as you can, but you also want to be, with the most safety possible. So it's not always easy. And I know the first experiments we did here, we had one experiment where people would like get very, very close to the drone, like very close. And we'd be like really scared because like, okay, what if somebody injures themselves? But at the same time, like we wanted to get the data, and technically we told them not to like walk into a drone, and so it's really something to always consider. How do you make it as safe as possible, but at the same time you still get what you need in terms of research? Do you mind if I take it after? I just want to go through a few more slides, and I'm sure then we'll keep time for questions. So the next step of what we've been looking at is, could we think about small drones that land on the body? And it's kind of going back to the work on wearables. And I actually got what is called an ISF grant. So it's the equivalent of the NSF Career Award. It's like a big grant that funds like your main research. And the idea was to say, could I have these devices flying onto me and away from me? But then is it like a wearable, like my phone, like a tool? Or is it like an extension of myself? Is it like having an extra power almost in my body through this? And so we're really trying to rethink what are the metaphors of having these devices coming onto my body and away from my body. And so one of the first questions was, would it even be okay for a drone to land on a person's body? So that was a preliminary work to even get funded for the rest. And actually, we found it is. So what you're seeing here is if you have a light color, it means that people felt that it would be acceptable to have a drone land on those parts of the body. So you see that the body parts change, but for example, the head is very often a no-no, except the very top of the head, which I'm not sure personally I would be comfortable, but this is like over 159 people. What's interesting is the groin area is always a no-no, no matter what's the position of the person. But then, for example, the upper body is much more open for people, and it really depends on the position that you're looking at. And so we were able to actually map this, and then we validated this. So this was with colleagues in Germany. So here's a student was supposed to come to Israel, and then we had COVID, and then he ended up doing all the research in Germany and not coming to visit us. So we did it on a mannequin because, again, you can't really take students to do that until you're 100% sure that it's safe. But what we did is we filmed in 360. And from this, we actually had a virtual reality study showing people what they would experience. They would still hear the noise, And they wouldn't experience exactly the same thing, but they would still see it and have a pretty close experience. And so that was a VR lab study where we had like 6 men and 6 women, and basically 2 different drone sizes, a very small one and the bigger ones, and again, a whole bunch of interview. I'm not gonna get into every level of it, but actually like people understood that the drone was landing on them. We found some aspects to be more acceptable, some aspects to be less acceptable. We looked at different behavior, different size. So again, just identifying what are the criteria that are going to matter. And so what we're doing these days is really rethinking and redefining what it is to interact with automated machines and what type of experience can we get with those. Is the experience the same if I have a drone that looks like this, or like that? This one is on the ISS. So it's like they're already using this type of drones. This was built in Japan, but this is like, oh, the flying dog, also from Japan. This is also one thing, whenever you see very cool robotics work, it's always from Japan, and you can be jealous, but basically the best, like the coolest robotics work always come from there. This is a drone that they have in a city. It's like a mascot, but they have this drone dog. We've done a lot of research looking at how the shape of the drone influences what people are willing to do with it, what they're willing for it to do, etc. And it's major, major, major effect. Even though the device may have the exact same specification, the exact same abilities, just by the way it looks, it entirely shapes the experience or reshapes it. I just want to end on something that we just started, but I think is super interesting. So we looked at videos on YouTube of people just encountering drones. And so we're starting to build a data set from this. And what we're saying is you have all sorts of experience that people are having. So some are having fun, some are like really unhappy about it. Yeah, can be very dangerous. And so the idea is to say, would we actually be able to detect, yeah, multi-user experience. And so would we actually be able to detect the emotional state of the person in front of that drone, for example? Are we able to affect the emotional state from the way the drone looks or behave? And if we could even just detect if the person is going to have a positive or negative behavior, we could change, for example, the position of the drone. And if you think about coexistence, this is what we do as people every day on, even on the street. If you see that you're crossing next to a person that looks really angry, you may say, okay, I'm just gonna go to the other side of the street. Or if the person looks very nice, you may smile at them. So it really makes a difference how we behave towards each other. What about creating technology in the future that can do the same? And so I'm just gonna end on this. We're actually recruiting. We have a couple of new projects, but one of them is looking at this crazy dog robot, which looks very, very scary. And I did not put the sound on purpose because the sound is even more scary. But the idea is like doing building exploration with search and rescue teams, for example, and having the drone supporting them with awareness of what's happening, detection, for example, etc. And then the other project that we're having is looking at exoskeletons. So this is one of my students, Eyal, who's very brave, who had to walk into an exoskeleton, and it's really difficult when you've never walked into an exoskeleton. But basically, we've been working with this company, and they have this amazing exoskeleton that's helping people with spinal cord injuries. But the problem is they're very, very difficult to use. Like the interfaces are a nightmare. You literally have to plug in a computer in USB to your hip, change the speed, unplug your computer, and go faster this way. It's really hard. And so what we're looking at is actually detecting upper body movements and very small movements, because the person is going to be usually disabled from the waist down. And so can we detect other body movements parts to actually help the exoskeleton understand the behavior of the person and then change, for example, their speed, their position, etc. So we're recruiting masters, PhD, and postdocs. So if you know anyone interested, let me know. And in general, I think that this is just the beginning. There is a lot more that we can do with those technologies, that they will open a lot more things for us. And I'm ready for questions. I think we still have a few minutes. Thank you. Well, I'll start with you because I saw you had a question earlier.
I was wondering if you think that the degrees of freedom of robots' motion could influence whether people think it's more friendly or more alive.
Yes.
Because if you had like even something coming from above, but if it was on rails or wheels, then that seems different from something that flies around.
So that's a very good question. So the question is about the degrees of freedom and how the movement may influence the perception and the perception of intent. So actually, I don't think it's the number of degrees of freedom so much as the movement itself. So we find that, for example, people are able to understand a lot of different intent and behaviors for movement. We started with this work actually during my postdoc here. And so we found that, for example, if it flies very low and slow and it stops, people understand it as tired. And so like, oh, the drone is tired, maybe it's out of battery. But then, for example, if it starts to fly in a very saccaded manner, then people are like, oh, there's something wrong with it. So actually people are able to make a lot of sense of the movement, even though we're not used to see drones flying. We're not really look at objects flying. I mean, the only things we see flying are airplanes, and they kind of go straight. Birds, and they kind of have their own lives. We don't have a good sense of how something is supposed to fly at what speed, but even then, people are still able to infer intent from the movement. And we can play with this, we can design with this, and this is super interesting. Yes.
Yeah, thank you for your talk. For the color study, have you considered colorblind people also? Because, you know, a portion of the people in society are colorblind and they can understand really the color.
Yes, okay, great question. So how do we deal with the colors with people with visual impairments and who are, for example, colorblind? So we did not, and this is not the best, we did not take it into consideration in that specific study. You have to realize that sadly, if you look at all the HCI literature, all the HRA literature, a lot of it does not take this population into consideration. So when you do a first study, if you want to build your work off prior work, you tend to like go for a generic population. But there are studies looking specifically at people who are colorblind. The thing on green and red is kind of terrible. The problem is like it's so ingrained into people's mind that very often when you do an elicitation study and you ask people what color would you use, they go for these colors, even though we know those colors are not ideal. So more work is definitely needed. And you know, this is something I always find when I come back to California. Whenever you go to Europe and you cross the road, you have the little green man or you have a little, you know, red one. When you go to California, you have a white person, gender neutral, and you have a red person. And it's like, oh yeah, this is California. And I think it's part of it. It's really understanding that, yes, colors matter. Not everything is going to be adapted for every population. But when you do research, sometimes you have to do like some choices. And I don't know if that's the best practice. I'm not sure if Michael or James, if he was here, would agree. But I think sometimes you have to base your work off of what other people have done as at least a first step.
I had a question about the firefighter cameras. So
Yes.
when you were using the different cameras,
Yes.
were there any changes made to like the reflectivity of their clothing or anything
No.
like that? Or it was just
So
the
we
camera?
literally took, we borrowed the equipment from one of the firefighters. And so it was the same reflective material that they have. So obviously, I'm sure if we use different equipment, maybe, so in different countries also have different style of hats, different type of reflection patterns that may have an effect as well. But we used the one we had available. Thank you.
Time for maybe one more, and then if there are other questions, you can come ask her after the.
Sure. Yes.
For the first, the search and rescue drones,
Yes.
it seems like a lot of the interaction rely on like hand gestures and motions. Have you considered like I just wondering like in cases where, because you talked about earthquake and things, like when there are structures and when people's movement are impeded and they aren't able to move their upper body like very like.
So that's a great question. So right now, voice recognition on a flying drone is nearly impossible. Like there is no, this is part of the problem. if the sound was always the same, you could filter it out. The problem is as soon as you have a bit of wind, as soon as you have a movement, the sound changes. And so filtering it out is really difficult. So we actually did a few experiments where we had like microphones coming like down from the drone. No, it's actually just an undergrad project, but it was really interesting. And from what distance do we actually manage to hear something that we can make sense of? And it's actually quite far down. But even if you look at all the literature on sensing and more like traditional robotics, nobody has really managed to crack it. So this is a huge technical challenge. Once this technical challenge is like cracked, I think we have much more that we can do with voice. What we're looking at right now is to say, okay, maybe the drone does not need to fly all the time. And so if the drone just lands, then you can start communicating with it in different ways. And then voice is a great way to do it, for sure.
Thank you.
Thank you.
All right, let's thank our speaker.